Good evening, everybody. Before I start, I would just like to thank Matthew and the rest of the committee for giving me the opportunity to do this. My name is Ivail Petrov. I'm a long-term follower of the group, first-time presenter. And as far as my Revit credentials go, I'm an Autodesk Revit professional and BRE BIM certified practitioner. I have been a Revit user since 2011, and I have been involved in BIM coordination since 2015. Currently, I'm working for a practice called AR Chamberlain Gaunt, or ACG, and I would like to talk about our module template for capacity studies. And actually, this is how the unit looks like. It's created as a generic model, and it consists of 3 elements. Each of those elements is a different subcategory, and that allows us to easily turn them on and off and control visibility inside the project model. So we have the external massing, which represents the external wall and half of each party wall, plus the floor that encloses the internal space. We have the internal mass, which represents the internal space enclosed by the external party walls and the floor. And then we have the balcony mass. Here we actually have 2 elements, one for projecting and one for concave balcony, but they have visibility parameters attached to them. So only one of them is visible at any point of time. And this is how the family looks like in the family editor in a plan view, along with its dimensional parameters. As you can see, in terms of geometry, it's pretty straightforward. But for us at this stage, it was important that all the metadata that we need for our schedules is already there and users don't have to worry about it. So it's the parameters where the family works the hardest. And we have 5 groups of parameters. We have dimensional parameters, which drive the geometry of the family. Some of them are instance parameters, such as width, length, the balcony dimensions, or the dogleg dimensions. That allows us to have a variety of unit sizes while having a minimal number of unit types. Other parameters, such as the internal and external party thicknesses, those are type parameters, which help us be consistent throughout the project. The next group of parameters, those are the data parameters, and they can be area parameters. Those are calculated parameters by formulas. Some of them can get quite long, or they can be number parameters that require user input and are used for actually generating the accommodation schedules. So such parameters can be number of beds, number of occupants, unit type, parking spaces required by truck, and so on. What's important to say here is that all of those parameters are shared parameters, and you'll see later why this is important. Moving on to the next group, those are the reported parameters. Those are all parameters that are driven by formulas and are only used for calculation of the various areas. For example, we have 2 parameters for wall thicknesses, the calculation wall thicknesses and the actual wall thickness. So the actual wall thickness is an instance parameter, which depends if the wall is thick as internal or external. It could take the value of the type parameter for external wall thickness or for internal wall thickness. And the same goes for the calculation thickness parameter, which is used for the calculation of the net internal area. If the wall is thick as external wall, then the value of that parameter is 0 and it doesn't affect the net internal area. The next group that we have is a graphics parameter. All of those are yes and no parameters, and they define if a wall is external or party wall, whether balcony is projecting or concave, or whether the position of the dogleg if the unit has one, or the type of roof if we're talking about house units. And then we have material parameters. Those parameters comply with our standards in the practice, and each type of unit has its own color. So this was as far as the family goes itself, and this is the most basic unit. What users see in the template is actually 125 instances of such families. 95 of those instances are residential units and 30 are non-residential. And in this slide, the units are color-coded by their type. So studios, 1 beds, 2 beds, 3 beds, 4 beds, and so on. And on this slide, the units are color-coded by their family. So we have 9 residential families and 1 non-residential, the one in gray. And the residential could have different shapes, rectangular, with a dogleg, with angled wall and a dogleg, multi-story with a dogleg, house unit with extensions, and so on. In terms of number of the families created, we could have put everything into a single family, but from past experience, we know that all-in-one families are never a good idea. We wanted to make things easy enough. So in future, if something needs to change, it's going to be very easy. Plus, because of their different shapes, the formulas for calculating the areas could get quite lengthy, quite complicated if we push everything into one. And in terms of the instances, again, it probably looks like a lot in a single template, but our goal is to make the life of the users as easy as possible. Here they have almost every type and shape of the unit that they might have in their projects. All they need to do is just adjust the size and arrange it in the plot. And when I say almost every size and shape, I mean that probably in 1% of the cases, the users might need a unit with an odd shape, which is not here in the template. And there's a workaround this. So they can build that unit as an in-place mass and use a Dynamo script to quickly push the area back into the unit. And this is how it works. Let's say that we want to chamfer that corner of the building here. All we need to do is create in-place model, make sure that it's a generic model, name it correctly, that's very important, and draw the shape that we want to. Now, this is a very simple shape. It's a very simple example. We're gonna move the original unit slightly so that we could take a look at its parameters, go to the area parameters, and see that all of those have values which are driven by formulas. The new unit has the same parameters, but there are no values for those. All we need to do is go to our script, choose what type of area we want to push, and there you go. Now we have the area here. The other thing that we can do is just type the other text parameters if you want to, and tidy up the drawing a little bit. Also, the script can work with multiple units. So once the user has drawn all their custom units, they can run the script once and you'll push the areas to all of the units. Here we have what the possible outcome that will be when it comes to graphics. And if we're talking about non-graphical output, rather than using Revit schedules, for our accommodation schedules for the thing that goes to the client, we are using a custom-built generic annotation family and a Dynamo script that extracts the data from our model and pushes it back to the generic annotations. The reason for you doing this is very simple. Every practice that I've worked for had their own format for accommodation schedules, and it usually included additional calculation with percentages or other stuff that were not possible to be created through a Revit schedule, or at least not with a manageable number of Revit schedules put together. This meant that schedules had to be created in Excel. And this is, and sometimes in some cases, I've seen people counting numbers on the screen and then typing the numbers in Excel, which obviously it's not perfect. First, it's time consuming. And second, there's a very high risk of error, especially when changes are made at the last minute just before submission. With using our custom family and the Dynamo script, we are not only achieving fast and accurate generation of those accommodation schedules, but we also staying true to the BIM principles and having our Revit model as a single source of truth rather than having the deliverables in 2, 3, 4 or more different softwares. And let me show you how this works. So we have a sheet with 2 views of the same project. We have 2 different design options here. And here we can see each view per design option. And here we have the 2 generic annotations. All we need to do is go to our scripts, run the residential one. Here we can choose which design options we can extract the data from. All we need to do is click generate and then select the generic annotations to which we want to push the data. We can do the same thing, quite easy, for the second design option. And push it back. So it's not the most elegant script. It could be done in a different way, much more user-friendly, but for us, it does the work, especially when we have design meetings or meetings with client. It means that we can have multiple options of the same project put on the screen, make the changes that we need to, and regenerate those accommodation schedules. And we usually work with percentages of the different units, and that means that we can see the percentages straight away. Now, we are using a master unit schedule that contains all the units used in our project, but we're using it only as a work in progress tool to manage all the metadata embedded into the units. So each unit has minimum net area parameter with its value already in there. And we have a column with a calculated column with the difference between the achieved and the minimum area. And this is a very useful tool for the teams to quickly check whether whatever they've designed has achieved the required minimum area or they have oversized the unit. Obviously, if that value is negative, the cell is going to be highlighted in red. And this is as far as what the template does for the capacity stage itself. But for us in the practice, it was very important that the template does much more than that. We wanted to aid the users once the project has passed the capacity stage and once it has progressed towards planning, to give them the opportunity to spend more time in doing what they like the most, designing and making their building pretty. So that's why we created another script which generates a different model from our capacity study model with wall, floors, roofs. And what's important about the script is that it structures the model exactly as we want it to be. A, it's compliant to our internal standards, and B, in terms of groups, it's efficiently organized. And let me show you how this works. So here we have a very basic generic model, capacity model. Each typical floor is grouped. What I'm going to do is I'm going to switch off the generic models just so they don't get in the way. Now I'm going to run the first part of our script. And here we get to choose type of walls and floors that we're using. And also we can play with the floor height if we want to. We can click on generate. We wait a few seconds. It's fairly quick. And now we have one instance of each typical floor. If we zoom in, we're going to see that there's some imperfections. So there are walls overlapping, but that can be easily fixed. Once we've done this, we can run the second part of the script, which is actually going to take those groups of typical floors and it's going to place them to their levels while remaining the group structure. And that's all that the script does. It's very simple. It's nothing fancy, but we thought that was very useful. It could save anything between a couple of hours to a couple of days of work, depending on the size of the project. And here, actually, this is the first project on which we've tested that, and we're quite happy with the results because we could switch between stages quite easily. And that's pretty much it from my side. Do you have any question, guys? I'll just
I put a question in the chat box, just more like an observation. I noticed you're using Dino, I think.
Yeah,
definitely talk to Data Shapes. They've got a really interesting project they're working on at the moment called Orchestra, and it's basically like that, but on steroids. Okay. And it's still in beta, but it's got a lot more features that are good for like a large company scale where you can manage it all in the cloud and deploy scripts really easily. So definitely worth checking out. Yeah.
Yeah, that's good advice. For us, the thing that I forgot to say is that we're using Dynamo browser, and for us, this was a game changer. Just because for our users, making them to open a Dynamo script could be quite scary for them. While if it's put just as a button in your custom tab, then we found out that people are much more likely to use that, and this is where we actually try to bring the most value at this point of time by saving time and showing to management that it's in terms of efficiency, there's much savings to be done with.
So we've got a question from Paul.
Yeah, hi. It looks really great. It looks really smart. I was just wondering if you tried it on any projects in different sectors.
We had an educational project, but because we don't have that much repetition of units, I think that they did it just as they first started with just in-place massing and then went to the conventional way, building walls around it. We haven't tested it. If we get the opportunity, we definitely will.
Yeah, great. That's what I was thinking. The repetition lends itself to this kind of work. You've obviously invested a lot in building the structure for creating the designs, and it needs to have that repetition to pay off. That's what I was asking. Yeah. No, great. Thanks.
Great. Thank you, guys.
Okay, brilliant. Have we got any more questions? No, I think that's it. Well, thank you very much. That was a great presentation. Now I'm going to hand over to Matthew, who's going to do a poll for us all.